Hello and welcome to this e-module on Uninterruptible Power Supply or UPS. Let's take a look at the learning objectives of this module. At the end of the module, you will be able to describe UPS and its significance, understand working of UPS and its related principle, classify the types of UPS designs, list the components of UPS systems, describe various battery types and their charging and discharging mechanism. Name the original equipment manufacturers, that is OEM, in India. Understand operation and maintenance protocol of UPS. Understand the maintenance of service levels. Explain the impact of UPS on businesses. Describe various issues and how to troubleshoot them. Uninterruptible power supply or uninterruptible power source, UPS, or battery or flywheel backup is also known as electrical backup systems. As the name suggests, a UPS or uninterruptible power supply is a system used to provide uninterrupted supply to the load at the times of mains power failure. Let us understand the need of alternate power supply in facilities. The importance of availability of power supply in a facility cannot be undermined, considering that almost everything in a facility requires electric power to function. Therefore, it is essential that some redundancy be built in to facilitate continuation of operations in spite of mains failure. The backup generators provide this alternate source of power and can provide stable power supply for long periods and can also take on the full load of the facility. However, the only drawback is that generators take time to start, stabilize and come on load, and there is an interruption in the supply to the facility which may range from a few seconds to a minute. The interruption may not be acceptable for some critical equipment like servers, which take a long time to reboot, and also for standalone computers which may lose critical data due to the interruption or maybe result in a failed transaction. This is where UPS comes in and provides instant power, thereby preventing any break in the supply to the equipment. It prevents sudden interruptions in the main power supply or power input by means of one or more connected stored energy sources, which could be batteries or flywheels connected to diesel generators. You all must have seen the UPS used at home for providing battery backup to the personal computer as shown on the screen. UPS used for larger applications serve the same purpose but are much bigger in size and may be used in different configurations to provide power backup to the various loads like large data centers, facilities, electrical engineering infrastructure, and other critical IT applications. UPS systems can be static or rotary or a combination and may be offline, line interactive, or online depending on the end use and criticality of the equipment supported. UPS systems are helpful in correcting the main supply anomalies like voltage spikes, harmonics, and fluctuations in voltage or frequency. Due to advancement in technology, a large number of processes are being automated. Therefore, there may be more than one equipment in the facility that requires an uninterruptible power supply. Thus, it is important to have a reliable UPS in a facility, as most electronic equipment cannot tolerate more than a few cycles of power disruption without shutting down. Keeping these things in mind, a UPS should be designed to protect critical and high-tech equipment and also to facilitate planned power outages so that technicians can safely transfer the load to a backup generator without interruption of supply to the equipment. The key factor in keeping a facility up and running is by having a thorough preventive maintenance program and a risk management approach that ensures critical services are available when required. In addition, regular testing of UPS equipment will help technicians gauge the health of the system, identify potential issues, and minimize problems caused by power interruptions. Many newer UPS also feature advanced monitoring systems that provide system status for such items as system voltages, battery backup times, and battery test schedules. Other information included in monitoring includes whether the UPS is operating on batteries, utility power, or maintenance bypass. Some UPS also can conduct a controlled shutdown for computers in a network when a low battery warning occurs. Let us now understand what is a UPS. The uninterruptible power supply is an electrical apparatus that provides emergency power to a load when the input power source or the main power supply fails or voltage level drops to an unacceptable level. It is also known as uninterruptible power source, battery or flywheel backup, and electrical backup systems. It is connected between the main electricity supply and the computer or electrical equipment. Now, let us see how UPS functions. A UPS ensures an uninterrupted supply to the connected loads connected by converting the energy stored in a battery or set of batteries or other energy storage systems to AC power at the required levels. The amount of time a UPS can sustain loads depends on the available stored energy. The UPS sustains the loads till generators come online or shut down the equipment safely. The on-battery runtime is around 5 to 15 minutes for smaller units. The UPS units range in size from units designed to protect a single computer without a video monitor, around 200 volt ampere rating, to large units powering entire data centers, more than 1 megavolt ampere, buildings, more than 300 kilovolt ampere, or manufacturing processes. Now the question arises, what is the need of UPS systems? Although the use of a UPS is not limited to any particular type of equipment in a facility, it is mostly or typically used to protect computers, data centers, telecommunication equipment, or other such critical electrical equipment where an unexpected and sudden power disruption can cause serious injuries, fatalities, serious business disruptions, and data loss. Apart from protecting the loads from power interruptions, there can be other issues with the mains power supply which can be harmful to the equipment. The table displayed on screen gives an overview on various issues with main power supply. Depending on the type of UPS system, UPS may cater to one or more of these power supply problems. Regardless of these issues, the main purpose of UPS here is to ensure continuity of power. Let us now see how UPS works or what is its main working principle. A UPS serves two basic purposes of providing backup power to equipment, which include charging the storage media, that is batteries or flywheel, by utilizing the available mains power, and converting the stored energy for use in the event of mains failure. The diagram on screen depicts the working of a simple UPS. The rectifier is used to convert the AC power into DC power. This DC power is used to charge the batteries and helps maintain that charge at optimal levels. When the mains power fails, the batteries are activated. The inverter converts the DC output of the battery to AC power. This AC power is then fed to the loads being served. The bypass switch ensures that the mains power can be fed directly to the load in case of a defect in any of the components of the UPS. The UPS can be deployed in a number of configurations. Let us see how. In general, there are three types of modern UPS systems, which are standby or offline UPS systems, line interactive UPS, online UPS, Apart from these basic types, there are newer versions like the hybrid UPS, rotary UPS, and DC power. Let us discuss each one of them in detail. Standby or offline UPS is the simplest design and provides most basic features such as surge protection and battery backup in the event of power loss or low voltage. In the offline UPS, battery or inverter are connected in parallel to main supply and is normally in sleep or offline mode. UPS may take up to 25 milliseconds to switch over to the battery mode and are not suitable for critical loads. The backup batteries are kept fully charged through a battery charger. The output of the batteries is connected to an inverter, which in turn is connected to the load through a transfer switch. Line interactive UPS is similar to offline UPS. The only difference is that line interactive UPS has an auto transformer built into the UPS which regulates the mains voltage without switching to batteries. It switches to battery only when power fails or voltage goes beyond a limit. Also, some battery power is utilized during the transformer adjustments. The battery consumption and transfer time is lesser than that in an offline system. In the line interactive UPS, separate battery charger, inverter, and source selection switch are replaced by a combination inverter or converter unit. When the line power is operating, the inverter charges the battery. When the power fails, it operates in reverse. Let us discuss the features of the online UPS. It is the most reliable system and provides continuous power to the protected equipment. Unlike the other UPS designs, where mains power is connected to the loads and UPS comes in only during a failure, an online UPS is connected to the load at all times, thus isolating the main supply from the load. Each module of the UPS may be connected to one or more battery strings. Multiple strings provide redundancy in case one string was to fail. In a parallel configuration, all the UPS supply to a common output bus, and in the event of a failure of one unit, the others can take over the load. An online UPS is also known as double conversion UPS, as the incoming main supply, that is AC, is first converted to DC in a rectifier. The output of the rectifier is then fed to an inverter, which converts it back to AC and supplies it to the protected equipment. It is connected to the load at all times, and the rectifier output is also used to keep the batteries charged. Since the raw power is not directly feeding the loads and the UPS and batteries are always in circuit, the load transfer in the event of a power failure is almost instantaneous. The raw power or mains power can be used as a backup in the event of UPS failure, and the UPS can be bypassed through a static switch to provide supply to the equipment if required. Let us explore the features of another type of UPS, dynamic rotary UPS. The dynamic rotary UPS uses a high mass flywheel or a combination of flywheels as the energy storage. These flywheels also provide protection against variations in speed and voltage, as these variations do not affect the rotational speed of the flywheel. A motor generator set with a flywheel runs on utility supply and supplies power to the loads. Upon failure of the mains power, the flywheel, due to inertia, continues to power the generator for some time, which is sufficient for an alternate static UPS to take over or for a coupled diesel engine to start and power the alternator. The distribution of the UPS supply is done in a similar manner as the normal distribution, but is kept separate from the raw power distribution. In the server rooms, data centers, where equipment density is high and where dual power sources are required for the equipment, the distribution may be done through PDUs, that is, power distribution units. In the previous topic, we learned about UPS system and its working. Now, let's look at the components of UPS systems. The major components of UPS systems are surge protection devices, rectifier stage and input filters, inverter stage with output filters, batteries, STS, that is static transfer switch or maintenance bypass, switchgear with protections, control panel or display screen. Let us discuss each one in detail. First component of UPS is surge protection devices. The transient voltage surges are harmful to the UPS and the connected loads. The rectifier, inverter, and the static switch, that is semiconductor, are highly susceptible to these voltage transients, and hence surge protection devices are installed on the input side and the output side of the UPS. When operating in bypass mode, the surge suppression is again required on the bypass input and output. Next component is rectifier stage and input filters. The AC input to the UPS needs to be filtered to lower harmonic current flow between the UPS and its source. The rectifier converts the incoming AC voltage to DC voltage. The output is free of transients, harmonic distortion, and frequency-related anomalies. The capacitors in the filter circuit also provide some backup for momentary interruptions in the main supply, thus avoiding switching over to batteries. The rectifier output is also used to charge the batteries. The DC voltage is then passed on to a voltage regulator, which ensures a constant DC output irrespective of minor fluctuation in the mains voltage. Similar to rectifier stage and input filters, inverter stage with output filters are also part of the UPS systems. The regulated rectifier output is usually fed to the inverter circuit, wherein the regulated rectifier output is usually fed to the inverter circuit, wherein the regulated DC is converted into AC at the desired voltage and frequency. This is a totally clean, regulated voltage and frequency output suitable for any sensitive equipment. Filters are used on the output stage of the UPS to reduce harmonics created by the inverter. They also smooth out the sinusoidal waveform. Next, let us take a look at STS, that is static transfer switch or maintenance bypass. Similar in function to the automatic transfer switch, a static transfer switch facilitates switching and automatically transfers the load from one source to another. STSs are semiconductor-based devices and use SCR, that is silicon-controlled rectifiers or thyristors for the function. Since there are no moving parts, the transfers are faster and smoother. An STS in a UPS system comprises of multiple modules which allow automatic shifting of load to another module in the event of failure of one module. It also includes an external bypass switch which allows for bypassing the UPS for maintenance. Another important component of UPS systems is switchgear with protections. The UPS system has an input and output switchboard that provide for instrumentations, controls, and switchgear for the input and output side. The UPS are generally fitted with control panels with display screens that can give you information on various parameters like bypass input voltage, bypass input frequency, input or output voltage, input or output current, input or output frequency, DC source voltage, DC source current. Apart from this information, the control panel also has alarms, various system status indicators, and control buttons to start or stop inverters. Batteries are the main power storage devices in most UPS. Multiple batteries are used in UPS in series or parallel to cater for the required voltage and backup required. There may be one or more strings of batteries per UPS to cater for redundancy. Let us learn more about them in the next section. Of all the components, battery is the most crucial component of UPS. Let us now understand what are batteries and their types. A battery is a storage device that converts electrical energy into chemical energy and stores it for use, wherein the chemical energy is again converted into electrical energy. In UPS, the rechargeable batteries are used, which can offer large backup time and higher voltages. Among various types of batteries, lead-acid batteries are most predominantly used and preferred due to their relatively lower costs, high power-to-weight ratio, better charge retention, and higher discharge rates. Let us now learn more about lead-acid batteries in more detail. The diagram on the screen shows a typical lead-acid battery and its components. The lead-acid batteries can be classified as wet cell or flooded cell batteries, or VRLA, valve-regulated lead-acid batteries. The wet cell or flooded cell batteries use the liquid as an electrolyte. They have a lower life cycle cost and last much longer. The disadvantage is that they are larger, require frequent maintenance and additional ventilation and containment for leakage. These batteries can be used where space is not a constraint. In a facility, they are generally used for starting a diesel generator. In the VRLA or SMF, that is sealed maintenance-free battery, the liquid electrolyte is replaced by a gel or an electrolyte-soaked fiberglass mat. The VRLA batteries have a much smaller footprint, do not require elaborate ventilation, can be mounted in racks, and are almost maintenance-free. There is no need to add water regularly in VRLA batteries and vent less gas compared to the conventional lead-acid batteries. VRLA batteries uses recombination of oxygen with hydrogen within the battery to produce water, thus preventing any water loss. Let us learn some more facts about VLRA battery. Typical battery voltages used are 12 by 24 volt, and the capacity of the battery is indicated in AH, ampere hours. The higher the AH, the longer the battery can sustain the load. In a battery string, multiple batteries are used in a series parallel combination to achieve the desired voltage and also the overall capacity to cater for the load connected. The battery bank usually has its own MCCB, which provide electrical separation between the batteries and the UPS and also offer protection in case of failures, overcurrent, etc. The VRLA batteries operate best at 25 degrees Celsius, and higher temperatures can have an adverse effect on the life of the battery. Therefore, it is important that the battery room temperature is maintained within limits. Let us now learn about how to maintain batteries. The maintenance of batteries should include following measures. Perform an annual load test on the battery bank to give a good idea of the condition of the battery bank and the residual capacity. From the monitoring purposes, visually inspect the batteries to identify any cracks, bulging, corrosion, sulfation, etc. Check the float voltage or current and ripple voltage or current. Monitor the internal resistance of the battery and connection resistance. Use battery monitoring systems to monitor the individual battery voltage, impedance, temperature, as also the string voltage and current, and provide alarms. Batteries are subjected to a repeated cycle of charging and discharging due to their very nature of the application. Thus, let us understand more about their charging and discharging behavior in detail. Most applications such as the UPS systems, the rate of cycling is generally far less. Let us now elaborate on different methods used for charging UPS batteries. There are 3 methods for charging the UPS system batteries. They are float charge, boost charge, trickle charge. The modern chargers are usually designed to charge a battery using any of these methods. Let us learn about each one in detail. Float charging is commonly used for slow charging of the batteries in environments where the discharge of the battery is infrequent and not deep. Charging the batteries at higher currents has its own drawbacks. Hence, a slow rate of charging is employed where a constant voltage is used to maintain the capacity of the battery. Boost charging is used in situations where batteries are drained heavily. This involves charging the battery at high currents for a short period of time. This charges the battery quickly to ensure availability during the next power loss. In trickle charging, a fully charged battery is charged under no load at a rate equal to its self-discharge rate. This enables the battery to remain fully charged. You must be wondering which companies in India manufacture UPS systems and batteries. Let's have a look. The top 5 manufacturers of UPS systems are Schneider Electric, Emerson, Vertivco, Eaton, Socomec, Numeric. The top manufacturers of UPS batteries are Exide Industries Limited, Panasonic, GPS Rocket, C&D, Yuasa. Now that we know who are the manufacturers of UPS, let us now learn about startup and shutdown procedure of UPS and its maintenance program. To start the UPS, close the main incomer breaker. Close the AC input switch on the UPS causing rectifier to start. Close bypass AC input switch to bring the bypass into circuit. Close the inverter output switch. Open the maintenance bypass switch. Close the battery circuit breaker. This brings battery into circuit. Start the inverter. When the inverter is ready, the load is transferred to UPS. Follow the given steps in reverse order to shut down the UPS. Now let us have an overview on what are the daily checks that should be performed during operations. These include clean the UPS room, check the UPS for cleanliness and verify to ensure they are dust-free. Ensure that the input breaker is in on position. Check for operation of cooling fans. Check the mimic display board for correct indications or any alarms. Check the load AMPS and investigate any deviation. Check the UPS for abnormal noise. Check the UPS for any overheating. Visually check batteries for any cracks and bulges. Also, visually check the battery terminals for any loose connection. Check the battery voltage. Check the incoming and outgoing cables and input and output panels for any abnormalities. The key factor in keeping a facility up and running is by having a thorough preventive maintenance program and a risk management approach that ensures critical services are available when required. Let us see what are the key features of UPS maintenance program. The UPS maintenance program targets two major components, batteries and the UPS itself. These are critical for the reliability and long-term performance of the UPS. The type of batteries installed and their capacity directly influences the type of maintenance tasks technicians should perform and their frequency. For example, smaller passive standby systems generally use sealed batteries that require little maintenance. Double conversion systems typically use flooded cell batteries that require monthly maintenance. Even though these batteries require more maintenance and are expensive, they offer nearly 3 times longer performance life than sealed batteries. The UPS itself also requires regular maintenance at least once a year. The technicians should take the system offline at least annually and inspect its components for signs of corrosion and heat damage. A thermal imaging system can be used to identify loose connections and components that can overheat. The UPS is a critical equipment in a facility. Thus, the improper functioning or unavailability of UPS can directly impact businesses. Thus, it is important to understand how the service levels are maintained. Following is the list of service levels that should be included. The operational availability of UPS should be more than 99% of the time. The UPS should be able to transfer load to batteries whenever the mains power is lost or voltage is beyond permissible limits. All PPM routines on UPS and batteries should be undertaken as per schedule. The maintenance contract should be in place and vendor response time and defect resolution time should be done as per agreed turnaround times. The temperature and humidity levels should be maintained as per standards specified for the UPS and battery rooms. All parameters should be inspected every hour and be recorded. Now let us understand why is it important to have continuity in power supply. How a power failure can impact the businesses. The power failure can throw the entire operation of an industrial facility, business, banking, telecom sector, etc. into jeopardy. Failure can be widespread, that is, total blackout of a region, or localized or confined to just one particular facility. In either of the situations, the impact can be tremendous and directly affect the business or operations. A power failure or power interruption can directly affect human safety and can cause serious equipment damage. It can lead to potentially hazardous conditions like loss of safety devices or control power and can result in disruption of production. Power interruptions can also have a considerable monetary impact, which can be direct, leading to loss of production, equipment damage, accidents, or can be indirect, leading to legal liabilities, loss of goodwill and reputation. Now that we know that UPS is a critical component for any organization, let us understand common issues with UPS leading to their failure and how to troubleshoot them. It is generally not recommended to have a reactive maintenance on UPS systems. If the UPS trips on an alarm, it cannot be put back without the consultation of OEM. A complete root cause analysis is mandatory for each event to prevent the recurrence of the event. Some of the common causes why UPS fails and tips for troubleshooting them are: the batteries are the heart of any UPS, and studies show that 20% of UPS fails due to bad batteries, caused due to temperature and cumulative discharges. To troubleshoot batteries, it is recommended to perform regular inspection and maintenance irrespective of their age or warranty status. During preventive maintenance, batteries are thoroughly tested by measuring their impedance or conductance to trace the performance of the battery and identify any potential internal failures. The fans may fail due to their own electrical or mechanical limitations or when their ball bearings become dried out. Some fans may perform continuously for more than 10 years, while others may run only for short periods before locking up for mechanical reasons. UPS contains a dozen or more electrolytic capacitors of different types and sizes, which helps to smooth out and filter fluctuations in voltage. Like batteries, electrolytic capacitors also degrade over time. Manufacturer rates the capacitor to work for 5 years of round-the-clock use, but it could potentially deliver up to 8 to 10 years of useful life under favorable operating conditions. When a capacitor fails, there might not be any immediate visible effects, but other capacitors must compensate for the additional workload, which shortens their useful lives. The capacitor failure may trigger the UPS to switch to bypass mode, during which it is unable to protect downstream loads. Regular inspection of capacitors during preventive maintenance helps optimize their operation and enhance their lifespan. There are other factors as well that can lead to UPS failure. Here is the list of some of the common events. Transient spike can cause damage to the input side of the UPS, including filter and rectifier. Lightning also can damage UPS and or connected load. A common misconception is that a UPS constantly protects the equipment load from lightning, but it primarily depends on the amount of energy in the transient. Preventive maintenance inspections can readily identify lightning damage and any appropriate repairs if required. UPS internal connections may be affected by vibrations from the building or machinery close to the UPS. Thus, thermal scanning of UPS should be done every 3 months to check for hotspots and checked annually with a complete mechanical revision on the full UPS and battery cabinets. The dust may block air filters and cause a UPS to shut down due to overheating. Hence, they should be inspected every month and replaced as part of an effective UPS maintenance plan. Although a UPS may have redundant power supplies, the power supply may suffer from input voltage surges, which can cause unexpected stress and overheating. Thus, it is recommended to have a regular inspection to detect potential issues. Sticking or welded relays may go unnoticed until emergency charge of state events occur. The periodic inspections can detect potential problems before they occur. The input filter is used to reduce input total harmonic distortion, that is THD, from the UPS to the input line. However, depending on the amount of input line electrical noise, the filter may attempt to correct harmonic distortion for the entire installation, causing overheated cables and chokes. Thus, the currents parameters and physical conditions of input filters should be reviewed and inspected. Following is the list of other preventive measures. Contactors are used to collect fine dust. Thus, resistive coatings, inspections and cleaning should be done on a regular basis to prevent premature failures. During a routine preventive maintenance visit, the motor operators should be checked and measured for proper operation while disengaged from the breaker. A technician should complete firmware upgrades during routine service to incorporate the latest operational enhancements to ensure compatibility with new load devices and to guarantee that the UPS is performing at optimum levels. It is important to verify the transient voltage surge suppression, that is TVSS integrity, and ensure that metal oxide varistor, that is MOV devices are functional and have not been compromised by excessive transients. That brings us to the end of this module on UPS. In this module, we looked at UPS and its significance. We understood the working of UPS and its related principle. We learned about different types of UPS designs and listed the components of UPS systems. We described various battery types and their charging and discharging mechanism. We also got to know about the manufacturers of UPS in India and impact of generators on businesses. We understood the operation and maintenance protocol and how to maintain service levels. We also described various issues and how to troubleshoot them.